We were given this worksheet to work on our big project. The direction says as the pistons of an engine rotates, it compresses and decompresses the air in the chamber. A compressed air and fuel mixture produces greater forces than an uncompressed mixture when the gas is ignited by the spark plug. To model the compression of a piston, this project will explore the relation between the volume and pressure of a 60 cubic centimeter syringe attached to the pressure sensor. There is no outlet for the air inside the syringe. The first question basically means is since we have the 5 cc increments shown in the table, we have to predict or find the next 3 cc's of volume is to account for the volume of air in the connect tube. Um, which will be shown in the data. The data shows that we have predicted the next 3 cc's or the 66 cc's, and in the scatter plot it shows that the most accurate prediction using a certain equation, which is y equals 25.1453 x to the power of negative 0.974. And to make sure what the pressure was, we input the value of x, which is 66, into the equation, and we got the answer for pressure, which is 0.425. If we look at the syringe, we can see the pressure and volume being inversely related. As you can see in the picture, if you push the handle of the syringe, the pressure increases and then the volume or whatever substance is in the syringe will decrease. So you can see that it is inversely proportional. So the pressure increases, so the volume decreases. So to apply both ways, if you pull back the handle or the syringe, the volume will increase because it'll suck up whatever substance is gonna suck it up. Uh, and it'll be contained in the syringe. But the pressure will decrease because less air will be the air will be mostly used up to for the liquid. So you can see it's related to the theory of Boyle's law because they are both inversely related. According to Boyle's law theory, an inverse relationship exists between pressure and volume. Boyle's law is used to predict the result of introducing a change in volume and pressure only, and only to the initial state of a fixed quantity of gas. If we look at Boyle's law formula, PV equals nRT. If we arrange the formula, V is equal to nRT divided by P, which means volume V is inversely related to P, which is pressure. As you can see in the graph, this formula is most suitable for Boyle's theory because as you can see there, the lines are inversely proportional to each other. When we look at the data, we had to create our own equation to show the function of the relationship between x and y. In FIF4, this standard assisted us on learning how to see the relation and graph the equation. In FIF5, this standard taught us how to find the domain and range in an equation and graph. After we created the equation, we can utilize the formula in order to help find y using the variable x for this big project. This standard helped us learn how to use technology to create the graph and to use the exponential function. The graph shows the exponential function but finds only x and y. To convert it into an inverse function, we use a square root to check the data if it's correct or not. These standards can help us in real life because in jobs and businesses, we still need to have a financial plan in order for us to see how well the company will be doing if they have these plans. And if by using the previous graphs, we can predict how long the company will last and predict the company's future financially if a certain equation is made. And lastly, these standards will be able to be used in other types of businesses, not only in large businesses but also as small businesses as well.